Hello and welcome to the show. My name's Relevant. This is Do All of the Things. On today's episode, I'm going to electrify my workbench, but not just electrify, DC electrify. I'm going to be running solar power to my workbench, building a small mini distribution system so that I can run my camera rigs off the solar power. Stay tuned. So if you've been following the comedy, you might be privy to the fact that I slapped some solar panels on the side of my house and built a modest solar system. It's about 230 watts capacity, or no, 270? No, I forget. With a 100 amp hour lithium battery, and I have the camera conveniently pointed over to the little control area distribution center. And what this does is it charges all my batteries. Since I set this up, any battery I own that's rechargeable has been recharged off solar power, including my phones, because I ran a line off that distro up to my room. And in a wall panel in that room, I set up a pupper kind of like this. Oh, come on, focus. So that I could charge my phones in my room off solar power. I'm also running my doorbell, and I kind of want to get other low voltage DC things around the house to run off this, but I'm still trying to figure out the best way to implement it and exactly how much capacity it's going to have. Now, one proof of concept I've been exploring the last month or so is running my camera systems. I purchased some particularly long DC to DC patch cables. Puppers like these guys right here, DC to DC. And as you can see, there's two patched into the panel right now. They're running my Atomos recorder and they're running my monitor for my overhead cam. And I had them running my ZV-1 and my audio recorder too, but they run off USB, and I had to dismantle that to be able to present today. This is the thing that I came up with. This I got from the local tire store, and then boom, I just plugged my old travel charger, my old car charger into there. This was important back when I used to live on the road, but lately I haven't needed it, so I'm going to repurpose it in here. I was going to use one of these guys, but you have to separately turn this on and off, and that's inconvenient. I just want this all to kick on all together. This guy has more than enough capacity, and this thing here even has a built-on USB port, though I need more than one. So the philosophy here that I've been exploring is people, they might set up a solar system, and then they get the inverter to turn it to 120 volts, and then what do? They'll plug a wall wart charger into it to like charge their phone, and it's like, bruh. We're taking low voltage DC, turn it to high voltage AC, then back down to low voltage DC. Oh, we need to cut out the middleman. And see, that is the case here. The Atomos recorder is rated for like 9 or 8 or something. It's up to 16 volts. It runs fine off that. My little Lilliput monitor is rated for 12 volts. It runs fine off that. A lot of these guys have little switching power supplies in them that will adjust variance of voltages, especially in camera equipment. They design it to run off a range of voltage so that you could, like, say, have a typical 8.4 volt battery pack, but then plug it into 12 volt power, and they don't have two separate power supplies. They just have one that has a sort of active PFC correction, just automatically adjusts. Now, as it stands right now, my Z50 has a 120 volt adapter. I need to come up with a power supply changing those two voltages, but for the most part, the rest of this, it's ready to go. So it's time to just permanize this, friggin' run power directly to the workbench. I just conveniently plug this all in without having wires stretch across to the back of the shop. So seen here is a rough estimation diagram of the plan. Here's that distribution panel up by the solar system. We're going to make some sort of extension cord. That extension cord is going to plug in to this junction box over here via this connector. Then it's going to go out to a switch that I can use to turn the system on and off. Otherwise these things will all use a little bit of standby power, even if they're turned off. It's going to go down to this junction here, which is not necessarily being correctly represented in its routing. In this junction, we're going to have a couple of fuse holders. I got these Russian surplus fuse holders. They will do the job quite nicely. One of those fuses is going to be for a DC jack. This is a 2.5 mil spec one, so it's not going to fit a lot of normal connectors, but I should have one that's a little beefier. Oh no, these are all the smaller ones. Well, either way, I have cables for it. This represents a 5 amp capable jack. And the idea is this is going to be general bench power. So when I'm doing like my little science experiments here and I need some DC power, instead of busting out a wall wart, plugging it in there, plug it in the other thing, boom, I'll just have like a plug on the bench, or at least near the bench, that I can tap power off the solar system to run my little experiments. I might want to build some sort of intermediary power supply to adjust on the output and maybe give some current limiting too, because, you know, stuff happens and that's a lot of current to have go wrong, but there is a fuse on it. This thing is hooked up to the switch in this drawing. It shouldn't be. I don't really care to switch this on and off. The switch is just for the camera system, so I might have to reroute this a bit. The other fuse holder is going to go to this 12 volt dealie right here. Got that from the local tire store. I'm not going to need that part. That's going to be part of the USB system. Another cable is going to go stretching from one side to another junction box. These squares here, by the way, represent the panels. So like this square here is the box itself. That square there is the panel that's going on the box, because that guy's going to get another fuse holder, and it is going to get a handful of these kinds of DC jacks, which will in turn, with these jumper cables, distribute power to the things that need them. So I need 3 of the, oh no, I didn't need 3 of these because one of these was powering the USB adapter. Oh, okay, so I only need 2 for now. Maybe I don't need 4 of them. So I have the Atomos, that's 1. I have the monitor, that's 2. At some point, I'm gonna be powering the Nikon. I guess 4 will be spare because, you know, I got other stuff here that eventually. For the switch, I pulled this out of junk. I've been trying to buy the least amount of components possible to do this, just using stuff that I have around. Like for example, I'm just gonna be using, you know, these kinds of boxes and these plain connectors. I'm going to be connecting this all together using 16 gauge 2 conductor SJ00W cable. This is kind of like heavy duty extension cord wire in the 16 gauge variety. The system's going to be conservatively or generously rated for 10 amps. And in some of my experiments, like, it should be okay to put these through this kind of connector. Under these applications, I don't know if I can actually recommend doing this way. It's just the way I'm doing it. I remind you all once again, this video is for entertainment purposes only. Now, one existential crisis I've always had is DC connectors. Like the ability to have some sort of nice plug that I can use for like 12 volt DC power, as an example. There's no standard that I could just easily pick up off the shelf at any given store. You know, you got these for the lower current applications, which are fine, but when I'm trying to pump a 16 gauge extension from one side to another, I need something a little bit more hefty. So that's where I found these guys are right here. We got the wire end connectors. These guys will go onto the wire itself to form an extension cord that will run across the shop. And then we got these guys, they're the panel connectors. And you see we have varieties of male and female, male, female. So this female one here that you can't easily touch or anything, that's gonna be the powered one on the panel. And then boom, extension cord plugs into there. And these guys are nice because they actually have grommets and stuff. They're weather sealed. These are outdoor rated, at best I can tell. Boom, 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 boom. That's gonna be on a wire. And then on the workbench side, we're gonna have the male counterpart to receive the power. And boom, I found these guys, they're nice. Let's look at them on DigiKey. They are made by a company called Chogori Technologies. Here's the part number for the panel end connector. Here's the part number for the one that mates with the panel end connector. Here's the other side of the extension cord that's going to mate with the workbench end. And here's the workbench end connector right there. There's your part numbers. These particular guys are solder cup rated, so they have solder terminals that we can fuse to. But they have a current rating of 20 amps. So I'm pretty sure they qualify for the applications that I would want to use them for. We're not doing 20 amps here, but I kind of am sourcing out connectors I could use for multiple projects as kind of a standard. And boom, 20 amps, that's great. I could have used these in the solar project maybe, even though that has its own standard. Oh, look at that, 45 to 105C rated. They have a maximum voltage rating of 300 volts, so I guess these don't necessarily have to be used for low voltage applications. I don't know that they have any UL listing to be used as like, we have standards for power transmission, so we don't have to worry about high voltage applications. This is something very specific and special. And you know, just for reference, there's many different versions of these. Like here's one with like a quick disconnect kinda. Yeah, so it's kind of intimidating to explore these options at first. We got 3 connector, 4 conductor. I think those are probably more signal grade or lower current. Oh, here's another quick disconnect version that's similar to mine. Oh yeah, see this is one of the wonky ones I'm thinking about. It's got 2 big honkin' high current connectors for transmitting power and then like a few smaller lower current signal style connectors. So that's a multi-purpose beast right there. Not even sure what kind of cable you would get for something like that, but I could see that being handy in projects I've done before in the past. So, where do we start here? Well, we're gonna pre-fit the accoutrement. We got 3 boxes, 3 blank panels. Boxes, I'll punch them as I see fit. I guess this one's already punched. I'll use this for like this guy. And so what I gotta do is I gotta start making holes, making sure that I clear wherever something's going on here. Just gonna have to get these screws out of the way. So this one wants like 4 of these. Oh yeah, I also got these connectors here. Ons a fuse, which will represent, yeah, that's the best way to represent what size holes you need, is to take the washers off. Gotta take them off anyway, right? And place the washers down. I just figured out that trick now. Or maybe I knew it before and forgot all about it. Yeah, so it's going to be easy to drill this from the other side because we can put it flat. Also lets us see our clearing. You got to make sure we clear this and notice that there's overhang over the box. So don't do it too close to the edge and maybe be like, okay, we need to be within this realm. So we clear these little, don't finish your sentence. It's not important. Not bothering to map this out in any way that is important. There's a circle. There's a really half-arsed circle. You know what, I'm just gonna put dots in the middle instead of mapping circles. They're not gonna be all perfectly in line, but whatever. That should do. Get this block of wood, where's my punchy boy? And their consultant. Pong. All right, the plot thickens. We're going to need to move all this stuff out of the way and make some room for Pressy Boy. Pressy Boy, Pressy Boy. Slap this on there. We're gonna need some bits, bud. Not getting far without those. Usual suspects are our cone bits. A little bit schmooed out with aluminum, but I'm sure they'll do the job. As I recall, this steel, I can't remember how hard it is to drill this steel. I'm gonna try starting off with a 1/4-inch hole and then enlarging it afterwards. Just gotta make sure the flingers don't fling in our face holes. All right, give us more height. Wish me luck, buds. Don't need luck for this, come on now. What I do need is a glove. They say you want to keep gloves away from rotating assemblies. I don't think that counts with a drill press necessarily, but in this case, I'm worried about the piece of metal getting jammed on the bit, then flinging around, cutting my hand open. Actually, this steel drills rather smoothly. I am impressed, sir. Might also be that this bit I'm using is not completely chowdered yet. Okay, we have our initial pilots. Only 5 of them, even though 21 is the trend these days. Got nice little curly cues poking out here, bud. Pretty clean holes, actually. Okay, so we need to get a hole. I'll go through this, which looks like it's gotta be 5/8. Let's try it. Oh, I'm seeing smoke. Okay, you know, you can't really read the numbers as you're going here, so we're kind of like dirt, 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 dirt. Oh, I wasn't even at 9/16 yet, bud. Hey. All right, that should do it. What do we got here? Where's our little scraping swiping? Oh yeah, bud. These tools are awesome. Oh, they're working great with this steel. All right, so, little tight, little tight. This is probably metric, you know, because it's not from around here. All right, let me just confirm something here, more intelligent-wise. What size hole do we need? We got 620. So what's that on this bit? Okay, what we drilled was a 615. The next step up is 682. I don't know if I want to make the hole that big. What do we have on the other cone? 681, 679. So no, just gonna have to manually enlarge this a bit. I can go oversized, but I don't want to. I want it to be snug. Sometimes this guy can just keep doing that. You can ream her out a bit, like so. Look at that, perfect. The only thing with these fuse holders is they have a little pip right there, a little index, so that they're an anti-rotation. But that's not really much of a challenge. How's this notch gonna do us? Oh, just a touch shy. Need a little bit more. Half we gotta round this out. I need a smaller round file. That's what I need. Don't I have one? Yeah, why aren't I using it? Bam, bud. That is snug like a glove. Boop-de-boop-de. All right, what's next? These things, I think they're just like straight up 1/2 inch. Yeah, 492. And I have 1/2 inch on here. Pretty sure it's gonna have that standard of connection on it. Yeah, there's 1/2 inch right there, 537. It's even a bit oversized. 4 holes, order up. Oi! Too hard, bud. Don't push yourself so hard. One more. Okay, now because we got 4 duplicate holes here, what we can do is let's pump that down to the 1/2 inch setting. And let's adjust our little depth gauge here to stop at 1/2 inch. And we don't have to worry about, there we go. That'll make the other 4 holes a little bit more convenient. Assuming our depth gauge doesn't drift away from us, bud. Oi! That's why I'm wearing gloves. This piece is rather hot now. Chamfer and DeBurr if you want to impress her. All right, fitment. Not like that. Yeah, that looks like that'll be relatively kosher, bud. I think I already have an idea how I'm gonna do this. We just have to do this a couple more times for the other plates. This guy right here, if I choose to use it, is 425, 7/16. Where's the file that I just had? I need a secretary to manage all my files. Oh, did I go a hole too big? I don't like that. I'm using this metal one because I want it to also serve as the ground, even though I'm not too concerned with grounding. Ah, yeah, she don't fit nice, bud. I made the hole too big. This guy's kind of oddball because it's got the threaded portion and then it goes skinny again. And then this outer bit's not much bigger than the threads. I'm gonna say this is kind of a crappy design, this particular jack. I have this other option for a 2.5 mil 5 amp rated jack. It's got some pretty dinky connectors on there for 5 amp rated, but it looks like it'll be a bit more cooperative. I don't know, we'll see which one I use. Now for the switch, YOLO Bomber. I think that's it for fab. Get this pressy boy put away and retool for, oh. I lost an eye. All right, so let's see what we can come up with here. I have ideas. But these ideas start with me securing these components down. Hey, they're just roly-poly everywhere. Oh, okay. That little pip on the fuse holder is a bit thicker. So let's shave that down a bit. Let's get all these guys into place. So we gotta make this make sense somehow. I do have some ideas. Okay, so I have some strategic positioning here that I'm hoping is gonna work in my favor. And I'm using 18 gauge solid copper wire, because I'm not expecting any one of these is gonna drain enough power to exceed 18 gauge. I'm gonna be putting a 5 amp fuse in there, and at this short of a chassis distance, 18 gauge should be plenty. I'm gonna chopsky this wire. We gotta get it all stripped down though. Okay, so for our negative bus, which I've already kind of planned wrong, I do believe it is these connectors here. So I got a loop-de-loop here, just like that. Hold on, for some reason I planned to connect that to there, but that's not correct. I need to connect negative to there. Did I say negative? I meant positive. Ta-de-da. You know, we'll just kind of wrap this around there. Ta-de-da, ta-de-da. Now I wish I had done this the other way around. Ah well, this should work. I'll make it work. And ta-de-da. Now we have an established to the fuse. Gonna move those in. I think I would like some heat shrink for this next run. We don't need heat shrink because I'm not thinking fourth dimensionally. Hey, you little poppin' fresh. All right, these bus lines are in. Bend this up, kind of stick it together, and boom. Now I'm assuming that I measured this all well enough that I have spare 16 gauge. I'm gonna be able to make the extension cord. I'm gonna have enough slack left over to get this done. Now, as per wiring standards for DC, black is gonna be negative and white is gonna be positive. Now, I'm just making these panels and they're gonna get moretted together. And this does not work on this wire at all. Turtifurgadur. And for the other side, something to the effect of turtifurgadur. Now, I just gotta assemble these solid wires so that they do not risk touching the positive wires. And I'm probably gonna duct this down. And I don't care if this ground line touches the panel. So, if I give this a snippy, that's basically how that's gonna work. This now gets installed into one of these boxes, much like, you know, typical AC fixture. And then I'm just gonna moret that to the wire when it comes in. I feel like I need another washer to shim on this thing. It's just Do I have washers this size? Not immediately accessible, sir. Somewhat surprising. I thought I might have had at least one washer this size. Ho, 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 ho. Oh, this thing's being annoying. What were they thinking with the design of this guy? Like, literally, I'm not digging on this jack. Like, they made that thread so bigger than where it lands here. Like, maybe if I put an O-ring in there, I'll get a nice fit, but then kind of, really? And yeah, like I didn't screw up the hole. Like if I go to the threaded bit where I measured, pretty much, bam, I wouldn't have been able to fit this through a much smaller hole. Poor design, Switchcraft, poor design. I think I've managed to get it mounted anyway. She almost wants to slide off the side here. She's not center. Wonder if maybe we could just do a little bit of, I think that actually did something. Okay, well, it feels reasonably solid. I'm gonna trust it. Change it out if it's a problem. See, I'm not too worried about grounding these boxes because they're not like, one of the reasons why you would ground a box where you usually use these 120 volt system is because if a wire comes loose, it touches the side of the box becomes hot and then it's an electrocution hazard if you touch the metal. The idea with grounding is that if that hot wire touches the box, has a path to ground, it can blow the fuse. In this case, there's a similar philosophy. But it's less of a concern because 12 volts isn't going to electrocute you. There's also a relatively low margin of error. So I did it upstairs in the bedroom because I don't want, you know, if something faults up there in the wall, I want to know about it. If this system faults, it's under more close monitor. So this guy, for one of these, I will use 16 gauge to get to this guy because I want this to be relatively load bearing. These are all center positive, by the way. Okay, this is going to be like a three-handed maneuver. Or no, I think it'll stay like that. Well, either way, with this particular connector, this will be grounded, so. Now, when I'm wiring a fuse holder, I make the center and deepest contact the input, and the side one the output. It doesn't really matter, it's just my preference. Now, mind you, in the case of the other panel, that center contact needs to be able to move with the installation, so we put that on the loose wire, whereas these stiff bits, we want to put that on the stiff connector. Now remember, before the fuse, you kind of want to use the same size wire that your entire system is rated for. That's good form. All right, so now this power output is now pretty much good to be connected. The only crisis here is, what were they thinking with this guy? So this guy here has a negative spade and a positive loop. I'm not exactly sure what they were thinking because it would make more sense the other way around. Sometimes you tend to screw these down to a ground point and then, you know, maybe spade them onto a contact block. Both of these are going to be friggin' useless in here. I think what I'm going to end up doing is just moretting these up like everything else. So unfortunately, these guys are getting chopped off and wasted. And then as for connecting this guy, yeah, more morettes. If I had a thought ahead, I could have like bust these together. Oh, this wire is 105C rated. That's some decent wire. All right, pretty much just boom, moret through a fuse to this guy. Now, the last thing left is Mr. Switchy Switch. We want to determine which side is the switching side so that I can position it the way I want. I'm gonna bust out Mr. Multimeter, set it to ohm mode, burping her, switched off, switch on. I will mark this side just so I know that's on. Because I have a feeling of where I'm going to mount it, and I'm going to want it to be inside towards me to be on, so that it can't accidentally be bump turned off. Now the switch plate, I drilled it offset because, you know, I never know what else I'm going to be adding to this. Might be a good idea to erase the old instructions, because that's definitely not what this is anymore. So I'm going to have this up, like that. Huh, it sticks out a lot. Is there some kind of chalk we can put in there? A spacer? What about this larger grommet? It'll be a rubber spacer. Oh yeah, that goes on there nice. Not trying to grommet the hole, I'm just trying to take up some slack. And there we go. Tension that nice. Gonna squish it to place. And that will prevent some rotation. I don't know what this switch is rated for. It says made in UK. I know it's a DC switch. This is like a car accessory switch. It should be good for the 10 amps that I'm rating this system at. Now, is this all gonna fit? Yes. It'd be sucked to be like, oh, you didn't clear your holes properly. Yeah, that fits good. And finally, yeah, that fits great. Everything's gonna fit great. Now, as far as wiring the switch, pretty straightforward. It's just getting some of these poppers right here, right? Never really liked crimp connectors, but, you know, they work. Snip and squish. Snip and squish. And boom, there we go. The switch is ready. Now onto these things. So, they're rear insertion, so you don't really have to worry. This is going to be, again, the panel side. We have to decide a polarity here because you're gonna notice there's no label. Like, which way do we want to put it? Like this or like that? I feel like I want it to be this way. It doesn't matter as long as we get the polarity right, right? I think looking from the back, I'm gonna go negative, positive. So from the front, it's positive, negative. Yeah, I'm getting a little bit nervous. Oh, we shouldn't need much more of this. We've only used a bit of foot. We'll use like one more foot. Actually, I should go look in the box to see how much I need. Not very much at all. I think I'm overcompensating with this much here. Strip it back. All right, so soldering to this thing. Get to see how well these take solder. Should take solder rather well. Holding this into place is gonna be the tricky. Well, I guess that works. Get it in there. Okay, that looks good. So, initial impressions. Maybe could use a little bit more insulation on the wire so these guys don't accidentally touch. But I think it's gonna be just fine. I gotta put heat shrink on it, actually. That's what I'm gonna do. Just to cover that section. I'm not too paranoid. Probably won't do this for all of them. All right, so double check. Yes, this is the one I wanna put in the panel side. And if you remember how that panel works, we need a spade on the positive and one of these puppers on the negative. All right. That should be ready to put in the box. Oh, this has to be an inversion, so positive and negative on this side. If it's gonna match, yep. Did I make these too shorts? I need enough to get a Marie on there. Okay, how are we gonna hold this little guy in place? Where's those chowder lips? By chowder lips, I mean the helping hands. They're just chowdered, right? Boop that snoot. You know what's good about these connectors? Whatever this, I don't know, epoxy is, it's not low temperature, so it's not like, these things don't feel like they immediately want to melt as soon as I touch heat to them. Okay, that's ready for box mounting. As for making the extension cords, I kind of have to lay that out. I feel like that's the first part of the install that I'm gonna have to do, is to get the extension cord all run across the ceiling. Let's get these boxes sorted. So one of these is gonna go down here somewhere. Yeah. To make that happen, I think I'm gonna be popping out this hole here. These guys are a bit tight today. All right, and these connectors that I'm not sure if I should be using. Doesn't even fit well, this old one. So just as an example, 16 gauge wire, go through hole, and then clamp it down. That feels just fine. So I have no problems with that. Oh, little tight. That has quite a bit of length for these boxes, so something to keep in mind. Maybe I should have got 90s. All these little screws, we got to get them back through these holes. Switch box is ready to install. This one is going to mount sideways, and that's going to house this arrangement. Yeah, I think that pretty much looks ready. Finally, this guy. So this is going to mount this way. It is going to house this stuff, either like that or like that. This is gonna come in from this side, so we're gonna have like one connector on this side that's gonna go to the other box and this thing. Well, we could probably put it in this orientation actually, now that I'm thinking about it. So for some reason on the diagram, oh yeah, because we need one that's gonna go out to the switch, coming out one side, and the main power connector. So yeah, that's the reason why I was doing it like this. Okay, well, give her. Oh, and herein is one of the great things about these power connectors. They fit rather nicely through the 1/2 inch knockouts, right? So you're gonna have that. Boom, extension cord just goes, easy peasy, dunny dealy. This one's used. This one's old. Okay, whatever. Yeah, that's ready to mount now. I am a robot. Meep, meep. Robot. Robot. Hold, hey, buds.